Hello, everyone. This section is going to be covering our annuities, methods of saving, and our investments. So, what are we going to do to save for the future? So, we've been looking at interest. Now, the word compound interest could be in some of our saving as well. So we can be getting charged that compound interest or we have to pay it. And so in savings, we get to get that money. So that comes up in our savings or our investments. So this first big one is the annuity. What is an annuity? It's a sequence of equal payments made at equal time periods. So you are making a regular payment to a savings. Okay, that could include an IRA, just a regular savings plan, any regular savings ones, but you have to make regular payments. Roth IRA, 401k, 403b. So an annuity, anytime you have a problem that says regular payments for saving, annuity, regular payments for saving. Because some people get this wrong on the test because it'll give compound interests information. And so they use the compound interest formula. No, it's an annuity, regular payment, different formula. So let's talk a little bit about, I think later it will explain these a little bit in this, but what is a traditional IRA? An IRA is just a savings plan that allows you to set aside money for retirement, right? So you can only do $5,500 per year if you're under 50. So you can only put so much money in your IRA, okay? And if you're for people under 50, oh, yeah, and then 6,500 for people who are over 50, and you do not pay taxes on money you deposit into that IRA. Okay, so you don't pay taxes on that. When you withdraw, you're taxed. So right now, the money will come out and just go to those accounts, whatever you set up for the IRA, or you could just do a lump sum every year into that IRA, but you are not, it's money that's not taxed. It will be taxed when you get it out. A Roth IRA, and you have a penalty if you take it out before you're around 60. It used to be 59 and a half, but I think it might have changed and gone up a couple years, but maybe it's still 59 and a half. And then your tax. A Roth IRA is a little bit different. You pay taxes on the money you deposit, and with you withdraw, it's tax free. Okay, so I take money I've already paid taxes on, then I go and put that into a Roth IRA. Roth IRAs also allow you to take out some of your, well, I think IRAs, some of them do too. You'll have to look. Some of them let you take out money like for like buying a home or paying for a child's college. So you don't have to wait without penalties, but not all of them. And then you have employer sponsored ones. So those are 401k and 403b. Those are where your company is taking money out for you. Usually they also add a certain amount of money for you into those 401ks or 403b. Okay, all right, let's look what we do. So the value of an annuity, how much it's worth, is the sum of all the deposits plus your interest paid. So the value of that annuity is all the money you're putting in. So I'm doing $100 a month for 30 years. I add up all those payments plus interest. Okay. An ordinary annuities are annuities where the payments are made at the end of each period. Annuity is due where payments are made at the beginning of each period. These are just technicalities on how they're taking out the money. Okay, that does matter for the interest, but it's not going to affect the way you do any of the problems. So here is the super ugly formula. Now notice the values or the letters are all the same. A is your future value. P is your payment on this one. Your regular payment rate, NT, all that will be the same. So let's look at this example. I deposit $1,000 into a savings plan at the end of each year for 3 years. The interest rate is 8% per year compounded annually. Find the value of the annuity after 3 years. Okay, so we are going to take our future value and how much are we putting in the account? Our 1,000. So you could think of this as a payment. Oops, that is not a P. It's like your starting payment. P is usually, I mean, it does stand for our um principal, but like for this, it's our principal payment. So it's a little, I would think of the P as payment on annuity. So $1,000 parenthesis 1 plus our interest rate was 8%, which is huge. We're not going to get that. The number of compounds is annual. So see how it's saying compounded annually? We are compounding our interest, but we're making regular payments also. So it's a different formula. And then you have to the power of NT. So N was 1, time was 3 years, and then we minus 1, and that has to be divided by your rate divided by your N. So when you put this into the calculator, you need to make sure you probably do the top, then the bottom, or that you use a big parenthesis around the top. But you should get $3,246.40. So that's the value of all of our payments and our interest at the end of 3 years. Because I put $1,000 3 times for at the end of each year. So I put in $3,000. And then the 246 is the 8% interest that you're getting compounded every single year. It's only once a year do you get that interest. So part B says, how could you find the interest? So the way that we find this is we do P times T times N, and that's going to equal the amount you paid. So for this one, I paid $1,000 for 3 years, once a year. So I paid in a 3 grand. So you have to use that to figure out how much money did you put in. And how much money did I end up with? 3,246. So I need to subtract the 3,246.40 minus the 3,000, and I can see I got $246.40 is my interest. So you have to be able to figure out how much money did I put towards this and how much did I make in interest? Okay. So problem 2, to save for retirement, you decide to deposit. Oh my gosh, I can't stop yawning. I'm either blowing my nose or yawning every time I make your videos. Oh well. To save for retirement, you decide to deposit 1,000 into your IRA at the end of each year for 30 years. You can count on interest rate of 10% compounded annually. That is one high interest rate. So A equals, we have our 1,000 as our payment, and we are going to do 1 plus our rate of 10% divided by, we are compounding it once a year in value of 1 to the power of 1 times 30 years. You have this minus 1 out here, all divided by that 0.10 divided by 1. Okay, if I wrote that too fast, you're welcome to pause the video. Okay, again, make sure you're getting my answer. You have to be able to put that into your calculator right. I get 164,494.02. That's a decimal. Okay, so I got $164,494.02. So I could have $160,000 in 30 years if I just put $1,000 away a year. Really, 1,000 a year isn't that hard to come up with. Okay, so find the interest. Well, how much did we pay? We paid $1,000 for 30 years, and we compounded it once a year. So we only put that in one time a year. Because what if we did 1,000 a month, right? Then that would need to be 12, which we'll have some problems of. So my contribution, what I paid is $30,000. Look at how much interest I made. That is amazing. So my interest is going to equal 164,494.02 minus the 30,000. Because this is over 30 years, so you're getting a lot of interest. $134,494.02. Okay, so over 30 years, I got a lot of interest. I only paid in 30 grand. Okay, cool. This will help you with saving and figuring that stuff out. Okay, this next problem. At the age of 25, to save for retirement, you decide to deposit $200 into an IRA at the end of each month at an interest rate of 7.5 per year compounded monthly. Okay, am I making a regular deposit? Yes, annuity, right? Regular deposit, annuity. So how much will you have when you're retired at 65? So at my future value, A is our future value. I am putting $200 into an account, and it's 1 plus our rate is 0.075, and we are compounding it monthly to the power of 12 times how many years? 65. So I was like, I mean, we started 25, so 65 minus 25 is 40 years. Minus 1 divided by this 0.075 divided by 12. Okay, so pause the video, put that in your calculator, make sure you can get this answer. $604,764.43. Okay, again, use a big parenthesis here if you want to do the division all in one. I like the graphing calculators only because I can see the whole thing in one. Okay, if you're using a little scientific, that's fine. Just figure out how to use it, and you could contact me if you can't get it to work right. How are we going to figure out our interest? Again, how much did I pay in? I paid $200 for 40 years every single month. So this time I had an in value because I paid 12 of those a year. So 200 times 40 years times 12 times per year. I paid in 96,000. Man, I still made such good interest. So the interest would be subtracting those two. Man, that's a high interest rate though, 7%. I don't know though, some businesses might have a good IRA for you that has a higher rate. I think mine when I taught in Idaho was 6%, which is pretty high. I don't know if they still have that because I'm in Wyoming. Okay, so planning for the future. The deposit P that must be made in order to get okay, so I'm not even going to read what they say. Look at this formula. What am I getting out? My payment, right? This is my payment. I want to know how much money I need to put away every single month to get to $1 million when I'm 65, right? Those are realistic problems to me, especially because I'm getting old and I need money when I retire, or maybe even for my child's, college, because college is getting expensive. So how much money should I put away? This formula is the same formula. They just solved for P. So look back up here at the other formula. If we took this formula right here and solved for P, we would times this over. So times by the A and then divide the top piece. So look what this formula looks like. Oh, A times the denominator divided by the numerator. It isn't a new formula. Okay, this book just doesn't make you manipulate the formulas. They just say you can use it. So you're allowed a page of notes. You should write this on your formula sheet. Okay, so you would like to have 20,000 to use as a down payment on a home in 5 years by making regular end of the month deposits in an annuity that pays 6% compounded monthly. How much should you deposit at the end of each month? Okay, I don't know. How much should I deposit? So my deposit is equal to my goal, my future value of 20,000 times my rate of 6%, compounded monthly. You'll find that often. In real business, you'll see quarterly as well, where it's a 4. And we're going to divide it by this whole big ugly thing. So parenthesis 1 plus 0.06 divided by 12, to the 12 times 5 years. Okay, minus 1 like this. Put this into our calculator. I have to put in $286.66 a month. That's totally doable. Okay, so how much of the 20% down comes from deposits and interest? All right, so I'm going to pay 286.66 a month to get to 20,000. How can I figure out what the two differences is? Think about it this way. I'm paying $286.66. I pay that every single month for 5 years. So it's still the same. P times time times N. Still the P times time times N, always. And this is your contribution. So it's the same even on these. What does that equal? 1,000. I got $17,199.60. So I'm going to contribute $17,199.60. What did I get out? 20 grand. That was my goal, right? So 20,000, that goal amount minus the 17,199 is going to get me the interest. That's our interest. So our total interest will be $2,800.40. So this is my contribution. This is interest. All right. Okay, so let's talk a little bit about other investments. So you're going to put money away. You're going to put money away per month. Usually, that's how they almost always work for IRAs, or 403b or 401k. So now let's look at a different kind of investment. If we are depositing money into our bank, it's a cash investment. So I'm taking money, I'm putting into a savings account, typically pretty little amount of money you'll make off of a traditional savings account. The account's interest rate guarantees a certain percent of interest in your investment. That's called your return on investment. So when I put my money into my IRA versus my savings account, they both have a return on my investment. Which one's better? I don't know. You would have to calculate it out that based on your bank and your IRA. Other kind of riskier investments are stocks and bonds. And a lot of people have never even thought about what is a stock, what is a bond, and haven't even considered putting money into a stock. So what is a stock? A stock, investors purchase stock. These are shares of a company. So when I own stock, I own part of your company. I own part of your company. Investors purchase stock and the shares of ownership in the company. So this example says, for example, if a company had issued 1 million shares and an investor owns 20,000 of these shares, that means they own 2% of that company. Now you have control of that company if you own more than 50% of that company. So a lot of companies won't even allow that many stocks to be purchased. So they still own part of it. So why would you do this? Well, you're going to buy part of the company and then you're hoping that company's value goes up and then you can sell that stock and make some money, right? That's what you want. Any investor who owns some part of a company is called a shareholder. You buying and selling is called trading, and you're traded on the stock exchange. Okay. When you sell your shares and get money, it's called capital gains. So I'm going to sell my shares, get money, I'm capital gains. While you own the stock, if that business is making money, they might give you dividends, certain percent of what. So if they make $1 million extra, they might give a certain percent of that $1 million to each stockholder, based on how much you owe or own, not owe. Okay. What is a bond? A bond, in order to raise money or dilute the ownership of current stockholders, companies sell bonds. Bonds are people who buy bonds are lending money to this company. So basically, a bond is where I'm lending you money and you return it with interest. Which one's riskier, owning a piece of a company or lending someone money? Owning a piece of the company. You don't know what that company's going to do, up and down. They still probably will pay you out that bond. So a bond is by far less risky than a stock. Now, a lot of people do a mutual fund. That's a mixture of the two so that they can make sure they want to be a little risky, but not too risky. Have you guys ever thought or heard about um, gosh, it was like early 2000s, so probably most of you weren't even born. Um, when WorldCom had all these people own stocks and bonds, and that company was cooking their books, so it was all fake. And so when it crashed, everybody lost a lot of money. And it was like, oh, put your money in WorldCom, put your money in WorldCom. And then it was like, oh, and no one has money. That was pretty bad. I think it was the early 2000s when that happened. Okay, so it is riskier to own stock. Mutual funds are a mixture. You can have a fund manager, you can have a portfolio of different diversified portfolio, different stocks, different bonds. Okay. Reading a stock table that I explain what each of them are in the note packet. Um, I don't, I'm fine with you reading that on your own. I don't really need to go through highs, lows, net. I mean, I'm pretty sure you can see those percentages. It's not something, if you're interested in stocks, then you can read that carefully, right? The rest of us are like, well, maybe, well, I am interested in stocks, but it just might not be something where you're at in your life yet or not. Okay, so here is the retirement pieces that we talked about at the beginning. Um, that you are Yeah, the definition, excuse me, just the definitions that we talked about at the beginning. Okay, so let's do one of these problems down here. Suppose that between the age of 25 and 35, you contribute 40 or 40,000, $4,000 per year to a 401k. And your employer matches this contribution dollar for dollar on your behalf. The interest rate is 8.5 compounded annually. What's the value at the end? Okay, so if I put 4,000 a year and my company doubles dollar for dollar, which the company I work for right now actually does above that, which is amazing. So, how much money am I putting in this account every year? I'm putting in $8,000. So that payment is 8 grand a year. And then you have your formula, right? For your annuity payments, annuity, 1 plus our rate of 0.085 divided by 1 because it's once a year to the once a year times 10 years minus the 1, all divided by 0.085 divided by the 1, right? Like this, put a parenthesis here. This is going to be your future value. Okay, put that all in. I would have $108,000, 680.79. And some companies will not give you their part that they put in for you until you're vested, which is usually 5 years. So once you're vested in that company, then you'll get the match. So usually they make you work a little longer. Usually 5 years. It could be 10. I don't really know. I've had 5 years at both the full-time jobs I've had recently. So that's how much money I'm gonna have in 10 years, 118,000. That's pretty good. Although I like to spend money, so that's only gonna last me probably 2 years. I'm gonna need a little more in retirement. Okay. After 10 years for working for this firm, you move on to a new job. Catch you later, new job. However, you keep your accumulated retirement funds from your 401k. How much money will you in um how much money will you have in a plan when you have reached age 65? However, you keep your accumulated retirement funds in the 401k. So I'm not contributing anymore. I did not do that right on my page. Your accumulated refunds. I put in like I was gonna get still keep putting that 8,000 a year. However, you keep your accumulated refunds in. How much will you have at the in the plan when you reach age 65? So this goes to just straight compound interest because we aren't going to make a regular payment anymore. We would take the $118,680.79 and we would do one plus our rate of 8.5, compounded once a year. One times 35 to 65 is 40 more years. Sometimes that's 30 years. Excuse me. I was like, no, it's not. So yes, because we're 35, 45, 55, 65, 30 more years. So do you see where on my paper, I used an annuity, but we're not making payments anymore. So I don't know what I was thinking when I wrote that out. So this goes back to our formula from our last section, 680.79 parenthesis 1 plus our 8% divided by 1 doesn't really affect it to the 30th power times 1. I get 1371742.44. Whoop, whoop, whoop. Holy cow, I would have $1,000,000 in 30 more years, and I'm not putting any more money in. I'm just keeping my 118,000. That's why it's a different formula. I'm not contributing $8,000 every year anymore. I'm just starting with that amount. That's a lot of money. That's because 8.5% is ridiculously high. Okay, what is the difference between the amount of money you will accumulate before 401k at the age of 65 contributed to the plan? What is the difference between the amount of money you will have accumulated? Well, I only contributed $4,000 every year for that first 10 years. So I only contributed $40,000 into that. I didn't contribute very much at all, and I got 1,000,000 something. So minus 40,000. 1, 2, 3. I get 1331742.44. I s- I made that over $1,000,000 in interest. Holy moly, that seems like something's wrong, but that's only because 8% is ridiculously high. All right, that is the end of the section.